Should we get started? Okay. So, thank you all for coming to what is basically a bonus talk, because unfortunately somebody wasn't able to attend. So I said I'd come and do one of my favorite talks to give. I've done various different ones of this particular talk around the same theme, and this is a newly reformatted version. So I hope you all get something out of this. So the idea is basically production. Production is kind of the only environment that ever matters, because nobody cares about your local machine, nobody cares about your development environment, your staging environment, your pre-production environment, your UAT environment, your security test environment, or whatever environment name you come up with, nobody cares about it. Because no CEO is going to say, great that it worked in UAT, but no customers can actually purchase anything from us, so we've made no money. But you know what? We're still going to pay you. So this talk is actually a bit of a passion project because my name is Martin Thwaites. I work for a company called Honeycomb. We deliver observability products. I'm not here to talk about Honeycomb today. I am going to be talking more about OpenTelemetry and observability after lunch in room 3, so do come and see me if you want to talk about that. But before I worked for Honeycomb, I was an independent consultant. So I used to go around to lots of places talking about observability and actually being a hands-on consultant and implementing things. And the last company I worked for before Honeycomb, I was brought in to build a bank. The idea was that they were working with an outsourced company using mainframes, HP tandems, if that means things to people. And that's basically how banking has worked for many, many years. They used mainframe systems because, well, transactionality and correctness and all of those things were really important to them. So they brought me and a couple of my friends in as consultants to come and rebuild this system. Now, we don't come from banking. We come from software development in general. And we spent probably the first month or two trying to work out how we were going to build this thing. And we quickly realized that actually what was important to the bank was correctness. They didn't care about essentially code quality. It wasn't really a thing to them. They really cared more about the correctness of the code. So that was a bit of a revelation, and we really started to think about how we could redefine the way that we built the software for them so that we could do the things that we wanted to do. Rapid release cycles, per commit deploys, all of that kind of stuff. And this is kind of a methodology that we came up with by piecing together lots of other different methodologies. So, quick poll. How many people in the audience would identify as an application developer? Somebody who writes software that your end customers end up using via a website or an API or something like that? Hands up. Okay, that's all of you. Okay, this is a bit awkward. Please don't leave, but this is a talk about testing. So testing is one of those things where I love doing it. Most people don't, apparently. It's second only to doing documentation. So this is a talk about testing. So I want to go back to 2020. 2020, this diagram was produced on a blog post. Anybody know where this is from? No? So this was Monzo. Monzo produced a blog post in 2020 describing their system. That is 1,500 individual microservices that make up the bank. And that kind of sent a bit of a tremor through the software development industry because that's terrifying. 1,500 microservices. Because when I started, that was the system that I worked on. You know, there was a person, there was an application, and there was a database. It was person, line, box, line, cylinder. That's basically every system that I develop. You could keep everything in your head. The entire code base was your playground. There wasn't external dependencies. You could run it all up locally and everything would be fine. But that isn't how modern systems work, because we can't just have one application anymore. We work in microservices. We work with independently deployable entities. We work with isolation. And modern systems look a little bit more like this. This is a very simplistic example, but the idea is that we have some services that users can touch with APIs. Web APIs being what we're talking about here. Those systems may interact with each other through synchronous communication, like an API. They may interact with each other through asynchronous communication, using some kind of event bus. But ultimately, they're independently deployable systems. And what I've found when I was consulting is a lot of people try and think about this as one big system. Essentially, that's one big blue box in that environment. And that isn't really the way that we should think about developing systems. But that's basically where all this talk came from. Ultimately, when we develop software, we're thinking about how do we get feedback on whether our system is working? It's all about feedback loops. The fastest feedback loop that we can have is the one that we want. Ideally, you want somebody to tell you as you're writing your code whether it is right or not, whether it does the thing it was expected to do. And we already have various feedback loops in our software. We have the first one being the linter. For languages that are non-compiled, that's pretty much all you've got. But the idea is a linter. It will tell you as you type each key whether you are using the right naming conventions, you're using the right indentation. Spoiler alert, it's tabs. But it will tell you these things as you're writing your code. It is the fastest feedback loop that we have that tells us whether the code is formatted properly, essentially. When we zoom out a little bit, compiled languages, we have the compiler. That will tell you how a class that you're interacting with, whether you're using the right objects, whether they're formatted in the right way, and it will not let you compile. You won't be able to deploy it if that doesn't work. It's a very fast feedback loop. We're going from milliseconds to maybe seconds at this point. We go out a little bit further, and then we have what we call developer tests. Now, developer tests is a term that we use for the tests that developers write while they're writing their code. Now, I'm not using terms here like unit tests, integration tests, component tests. Any of those kind of names which people have a very strong attachment to, shall we say, about what exactly they mean. So when I say developer tests, I'm talking about the tests that you as a developer will write during the life cycle of your code. And those provide us with a lot more feedback. They'll tell us whether the code is doing what we intended it to do. We zoom out a little bit further, and then we have end-to-end tests. What I'm referring to there is tests that will run in a deployed environment, where we'll integrate all of these different services together. We'll test the messaging. We'll test to make sure that the APIs return the right thing. They go through all the way to the end. Thinking in a banking context, I can create an account, I can add some money into it, I can take some money out, and I can get a statement at the end of the month, that being an end-to-end test. Now, each time we go out in this scenario, it takes longer. It takes longer for us to receive the feedback to know. We go a little bit further out, and then we have production telemetry, which means that we're going to be able to know what's happening in production. If we've wrote our telemetry right, we're going to be able to know what's happening and when it's happening. And obviously, the ultimate feedback loop is customer complaints. Because let's be honest, they are a feedback loop. I would say the time in which it takes for us to get that feedback loop does vary based on customer. Some of them are really, really vocal. But ultimately, those are our feedback loops. As developers, that's what we want. We want feedback as to whether the code that we're writing is doing the thing it intended to do. I want to zoom in a little bit on developer tests. Now, a lot of the time, I apologize about the color on this. I have been told it is a bit hard to read. That says methods in the middle of there. Now, when we talk about unit tests, what a lot of people believe a unit test is I have a method on a class. We're in a .NET conference, so we're talking about classes and methods. But I've got a method on a class, so I hit that method, and I make sure that it returns the right thing, or it hits my mocked version of another method. So I'll new up a class, I'll inject a load of mocks, and then I will make sure that when I call this method, it calls that mock. I'll be honest, those are pointless tests, stop doing them, but that's a different talk entirely. But that's really minutiae of detail. It's where we tend to live at the moment. It's a safety blanket. We might go out a little bit further and then think about a class that has multiple methods. And we'd write a unit test for a class. A test as a developer that I write that makes sure that class does what it says. We go out a little bit further than that. You might write a test around your controllers and handlers. Now, the visualization that I've used here is very explicit, because what I'm not doing here is I'm not just testing the controllers on their own, I'm testing the controllers with the classes under the hood. Now, each time we go out, we call this changing gears, because we can test more things with fewer tests if we go out a bit further. If we go out, ultimately, we go to the thing that matters. Because the thing that matters is the APIs, the messages, the events. That when I hit an API, I send in a message or I respond to a message, something happens. An output will happen from that. That, to me, is where when we're talking about developer tests. It's just tests that a developer writes, and it could be any one of those circles. What I've found is that people really like living at this level. Because, well, I can reason about the methods. But again, you know what your boss cares about? That. No boss is going to go, oh, I really like your 4,000 unit tests on that class. Really great. But nobody can use the system. But it's all right. You just keep writing your unit tests. And then we come on to my favorite meme ever. Because I think it very succinctly identifies the problem when we talk about developer tests. We talk about unit. It very succinctly tells us what exactly the problem is. Because as soon as we do our unit tests, we very rarely do those external integration tests. So how many people in the room have wrote some classes in their .NET code, in their web API, wrote all those unit tests, made sure they worked, and then hit play on Visual Studio and realized they forgot to add it to their DI container? Anybody? There's a few people who are truthful. The rest of you are liars. Because everybody does it. It's human. We forget. I want to go out to back to that diagram. In this diagram, what we have is a distributed system. There's a couple of synchronous bits of communication, but most of this is asynchronous. Ultimately, in this system, the only thing that matters are those parts. The connection points, the contracts. Nothing else matters in that diagram. Nobody cares about the message bus. Nobody cares about what's inside of those blue boxes or inside of the databases. What they care about is the connection points. You might have a connection point where you extract your database into a data warehouse. Now you've got another connection point. The connection points are what matter. because the connection points are what allow us to have a system that works all together. Each one of those individual systems has a contract that it is outputting. It might be a message contract for Service Bus. It could be an API contract for a web API. But in order for us to be able to work in a scalable way in organizations where we have potentially 1,500 microservices. Side note, I spoke to somebody at Monzo recently. Apparently it's 3,200 microservices now, which is even more terrifying. But in order to work in those environments, we need to isolate our systems. Because nobody can keep 3,200 microservices in their head at any given time. I struggle to keep one, to be perfectly honest, but that might be a me problem. But those are the things that matter. Now, each one of those connection points is driven by a requirement. Now, we might work on a requirement that is a system as a whole, and then work that down to individual service requirements. So let's look at an individual requirement that might be something that we do here. So let's just say the product service. The product service list products endpoint should not return products that have no stock. Very sensible requirement, quite succinct about what it's doing. Well, that identifies some connection points, some behavior that it is that we want. So our product endpoint, when we receive a message for the stock being changed, we need to update the database so that when the list product endpoint comes back, there isn't those products in. That's a requirement that we've got. And it's a requirement for connection points. Now, I could go in and start, right, okay, so which classes am I going to create? What methods should they have? And you probably will do that at some point. But ultimately, those do not matter. The reason they don't is because writing tests at that low level makes our code brittle. It makes our code resistant to change. Because whenever you were to change one of those classes, do a bit of refactoring and say, oh, it'd be great if we added these properties to these classes or combine these two classes. All of a sudden, all of your tests have now been invalidated. As soon as you update a test, that test cannot be trusted to tell you whether it works now the way that it worked before. However, that requirement still needs to be fulfilled. Now, a slight anecdote from the bank was we had an entire system that was built on running outside in tests like this. One of the teams that we had hired in, they spent, I think it was about 8,000 tests that they had from the outside, like testing these requirements. They ran in about 10 seconds because we were using web application factories and in memory and all the rest of it. And they realized when they got a new requirement in that the data model that they were using was wrong. And they had to refactor the entire internals of the service to use a different data model. They actually moved from using event sourcing onto a relational database just for that particular service. And they did the whole thing. Took them about a week. And then all of the tests continued to pass. All of them. All 8,000 of them. Because they'd still fulfilled the contract. It then took them 2 days of procrastination because they were, I can't just release it. Like, but all the tests are passing. Like, yeah, but we've just done all of this work. We've gutted the system and rewrote every single line of code in the system. It's like, yeah, but the tests are passing. You've fulfilled the requirements. Just deploy it. It's like, yeah, but it doesn't feel right. We need to do more testing. I'm like, do you not trust your tests? Because if you don't trust your tests, we've got a bigger problem. Because if we're doing things from the outside, if we're thinking about the requirements of our service, and those are the things that are written as automated tests, if you like, we can trust it. Now, that particular service that we've got there, the product service, it doesn't care where the stock changed message comes from. It cares about the contract of that message, and it cares that it comes in but it doesn't care about the stock service, the warehousing service at all. It doesn't need to, it shouldn't. It's outside of the remit of that particular service. The warehouse service, however, does have its own requirement. The warehouse service should emit messages that contain the new stock level for a product whenever an order placed message is produced by the order service. Again, we've now got a requirement. Because, well, when the order placed message comes in, we produce some messages out the back. Really easy. Now, I did lie before. It's not really a talk about testing. It's actually a talk about TDD. Because ultimately, when we think about requirements, we've now got a requirement that we can fulfill. Now, a lot of people believe that TDD is about unit testing, about method testing. And when I speak to a lot of people who go, oh, I can't do TDD. TDD is way harder. It takes way longer. It's really because they're thinking about TDD in the wrong context. That is TDD. We write a test that fails, that defines a behavior, a requirement, that we want our system, service, class, whatever to do. We do the smallest possible thing that we can do to make that test pass, and then we refactor, and then we just do that cycle again. Now, if we were to write all of our tests about the requirements that we're given from the business, we end up with a much, I don't want to say better, but a much more resilient system. Because the only things that we've built into our system are based on the requirements that we've been asked. We've not built things because, well, we think we might need that in our class. It's like, well, we should probably have a method on there that does this. Does anybody use it? Because if nobody uses it, you've basically built something that you have to maintain, which is a problem. Now, another anecdote from the bank. I'm a bit of a pedant. I like being pedantic. It's great. And we adopted this methodology that we'd only write tests that are based on the requirements that we're given by the business. Which meant that we wrote small amounts of tests, but we never wrote any code unless there was a test covering it. Because the test was what they told us they wanted. So no test, no code. And we spent about 6 months. We weren't live because we were still building this thing. It took us about 2 years. But we spent about 6 months where the BAs kept coming to us and saying, there's a bug. I'm like, oh, I'm really sorry, what's the bug? It's like, well, when the user tries to spend more than their balance, it doesn't throw an error. I'm like, oh, I'm really sorry, can you point me to the requirement in the thing so we can track it back? They went, oh, there's no ticket for it. We just assumed that you'd build that. I'm like, well, if you haven't done it, it's not a bug. This is a feature you haven't told us you wanted. Because we weren't building things because we thought they were useful. We weren't building things because we believed that that was a feature we needed. The only features that we ended up building came from requirements, which had this really awesome side effect that we were always achieving 100% code coverage in our tests. 100%. I hate code coverage metrics. They're useless. Not entirely useless. Code coverage metrics are a negative indicator, not a positive indicator. They're an indicator that you have a code path that has not been tested. Having 100% code coverage does not mean you are done. Not having 100% code coverage means you're probably not done. Because it's telling you that you've got a case that you haven't tested yet. But if we're going to use code coverage metrics, I'm damn well going to make 100%, okay? So every single time that we ended up with a line of code that wasn't tested, you could do one of two things. Work out what requirement was missed and talk to the BAs and get that a requirement in. Or alternatively, delete the code because it can't be hit. One of two things has happened. That's the only two things that could have happened. So when we write these tests, when we think about the outside in, what we have is a system like this. We have some tests set up. But what we end up doing is we end up using our system as part of the tests. We send in stocked received events, so we have stock coming into the system. We emit an order placed event as part of our tests. And then we ensure that the stock changed events come out in the right format. That's it. That's the entirety of the tests that you need to write. Because inside of that warehouse service, inside of that blue box, nobody cares. There is nothing inside of that blue box that matters if the outside works. What we didn't do was we didn't do that. We didn't run our test setup and seed a database. Because I'm taking a wild guess here that none of your customers have direct access to your database and insert their orders via SQL. There's a few people in the audience saying, no, that's what our customers do. SQL is our API. I've worked in those companies too, don't worry. But ultimately, that is what we're trying to do, is we're trying to see whether that stock changed message is output when the conditions are met. That's the only thing that the business cares about, so it's the only thing that you should be writing. Now, that's not to say don't write any tests at class and method level. Those are generally good tests to write. They help you design APIs. They help with thought processes about how you might design those internals. But leaving those tests around makes your code base resistant to change. Writing tests at this level is a higher gear. Going back to the gears discussion, if we're at our unit test level, we're at our methods, we're in a very low gear in our car. We've got lots of maneuverability, but we can't go very fast because we've got to do every single one of these things. If we zoom out and start thinking about our system, we can go a lot faster. We can test more things with fewer tests. We can have more meaningful tests that describe our system. Our tests describe the behavior of our system. But it's all about being able to switch gears. It's not about just write tests at the outside. It's not about just write tests at the inside. It's work from the outside in. When you're on the outside and you're trying to write a test and you realize that actually, no, I can't understand. I can't test this particular behavior because it's an internal characteristic of the system. Well, ultimately, you should ask the question, should I externalize that? That behavior, is that something that people want to know about? So actually, I lied again. It's actually a talk about observability. Do you like the bait and switch there? Because internal characteristics of our system are important. When we debug our system, we need to know what's going on the inside. So insides are important. This is a quote from Charity Majors, who popularized the term observability in the context of software. I'll talk a lot more about observability in the next session and what it is and why it's there. But ultimately, observability is about understanding and debugging unknown unknowns. But the thing that I like most about this statement is this part. Because it allows us to understand the inner system state of our software, what's inside the blue box. Because what's inside the blue box is important. If it's important locally, for you, if it's important enough for you to write a unit test about it, it's probably important enough for you to know about it in production when you're trying to debug why the idiots of users, God, users can be idiots, but why they did something in a particular way. Well, knowing what happened inside of the system is really important. So that's the system and the service. We look at a system as a whole. This is a trace view, a trace waterfall, which allows us to be able to see how a user has used the system, but also how did the system respond to that user using the system. Each one of those ones in the second column is a service, an individual blue box, so we can see what's happening inside of each of those services. So how does this relate to outside in testing? Well, if we want to stay on the outside, if we want to stay in 6th gear and run really fast, write all of these tests, but we do still need to know whether something on the inside happened, we can use observability during our development. We can use telemetry, that production telemetry, in our development lifecycle, in our developer tests, to establish whether that thing is happening. We call this observability-driven development, which is the idea that our observability, the telemetry data that we put in, how we view that, how we ask questions, is something that we use to design our systems, to help drive the development process, to design our interfaces, to design how the outputs of our system, of which telemetry is an output of our system, helps us design that. It helps us build a trace view like this, because we're able to know on each one of those levels what's going on inside of the system. And if we can't, when we're running locally, see what's going on, we're not going to be able to see in production. And I go back to what I said at the start. The only environment that matters is production. So if you cannot work out what's going on in production, you've got a problem. So here's an example, because ultimately, most of the things that you would develop have an external output that matters, that you can see. It might be a message, might not be a message. But there are some things where the outcome is the same, but what happened on the inside is different. Now, the particular example I've got here is about pricing strategies. Think discounts, vouchers. If you've got a product that is worth £10 or €10, if I have a voucher code that is going to apply 10% off, well, the outcome of that is the price is €9. But if I also have a pricing strategy that takes £1 off, I also end up with a price of £9. Now, it might be that that was actually the wrong pricing strategy, but the same outcome. So when I'm writing a test, I need to know that it used the right pricing strategy. But guess what? When I'm in production, when somebody complains that something wasn't right, I also need to make sure that the code used the right pricing strategy, which means that that observability output is actually really important to me. So in this example, we go for an individual product. We're going to go and get the strategy that relates to that product. We're going to then, for that product, get the price. And then we're going to apply the pricing strategy to the product. Now, I purposefully mashed together 6 different languages to try and make that example work, so nobody tries to look at it as .NET. You can come to me afterwards and tell me what you think influenced it. So when we write a test for that, and one of the things I want to talk about here is the test name. Because I'm talking about my get product endpoint. When it's got a valid product, it uses the right strategy. That test means something. It's a human readable requirement, which means my tests are readable by business people. They know, all right, well, yeah, you've got a test that tests that thing. But how do we test it? And we do this using something called the Web Application Factory. In .NET, it is a really awesome tool that will run your entire API in memory. In this scenario, I've called my web application factory ecom service, and I've got a few wrappers around it that hit all of the different endpoints. So when I go get product, I return a product. I assert that the product price is this. But how do I know that that product price has used the right strategy? I don't. So for that, we use tracing, logging, something of that ilk. In this scenario, we're using tracing and spans. So what we do is we go and get what our current span is that's running, and we just add a property to it that says this is the pricing strategy. It's that simple. Because what that does is allow us to be able to assert that we got that out, which is really, really important. Because now we're able to test that when we support this in production, we're going to have the information that we need in order to support it. Because production is scary. It's this big black box that exists in sometimes in another country. It's a really scary thing. But if we can use these outputs and we design them as developers, then it becomes less scary. The way it becomes less scary is because when we run our tests, we can actually see the observability outputs. This is a trace view for a test. Because the test matters. This is actually a to-do list API. This is an example that is on my GitHub, where the first call goes and gets something from the database, and the second call returns it from a cache. I get to know what a valid trace would look like. So I know what I'm looking for when I go into production. When I go into production, I can go, it doesn't look like this. Why? Why does it not look like this? And I can go back to my development. I can add more tests on the outside, more requirements. Still doesn't look right. I can add more observability, so now I can see what's going on. And ultimately, what we start to do is treat our local environment like production. We use the same tools locally to understand what's going on as we do in production. Because you can't attach a debugger to production. I mean, you can. You can absolutely attach Visual Studio to a live running IIS instance. You only ever do it once. Because for those too young to have had access to do that, because I realized recently that I am actually a little bit older than some people. When you do that, it stops every thread on the server, which means every single user that is trying to use your system right now hangs for the amount of time it takes you to debug. Don't do that. That's not development advice, that's career advice. So actually, this is not a test. This is not a talk about testing or TDD or observability, really. It's a talk about writing fewer tests. But it's about writing fewer tests in a higher gear that get us to our destination quicker. This is all about, can we write tests that define our behavior of a service, of a system? So I want you to walk away from this with a few key points. The first one is to think about the gears that you're in. Am I in first gear because I'm trying to maneuver around something that is really, really important? Maybe it's you're using event sourcing, and you want to test your view models in memory. Maybe that's the right gear to be in. If you're on the outside, and you're testing something and you're finding it really, really hard. If you're testing something and you're finding it really, really hard to test on the outside, is this the right gear to be in? Should I reach inside? Should I go lower and write some tests down there and then come back out again? Know what gear you're in and think about whether it's the right gear for the test that you need to write. Secondly, write tests that matter. If you're writing a test that sets a property on a class and then asserts that that property is set, that is not a test that matters. If there is no logic in there that you are testing, it is not a test that matters. I've had so many people come to me after these talks and say, that makes so much sense, but the tech lead keeps telling me I need to write all of these tests. And the only advice I've got for you is leave. Write the tests that matter. Think about why you're writing the test. Think about whether you want to delete that test after you've used it to help define your API. Don't feel bad about deleting a test. I do this all the time. Write a load of unit tests, they help me feel out how I'm writing an API, and then work out, do I actually need to keep them? Delete those tests. Have overriding tests or covering tests in that sixth gear, and then remove those unit tests. Write the tests that matter. We only have a certain amount of keystrokes in our life. Use them properly. Third one is don't make your applications brittle, resistant to change, which goes to the previous point. Write tests in a way that means that they don't make your application resistant to change whenever you need to add a new feature. Because as soon as you do that, you lose confidence. Going back to the banking example, we wanted to run fast. And it turns out that banks really care about whether you spend more than your balance. Those tests mattered. And it turns out the reason why they care whether you're spending more than your balance is so that they can charge you a lot of money for doing it. Because you can still spend more than your balance, which is what we found out when we started looking at the requirements. And the final point is think about your requirements coverage. Think about when you're writing your code, am I covering all of the requirements that I'm asked for, or am I writing tests that weren't actually requirements that I've been told? They're my perception of what a class should look like that would fulfill an outside requirement. And the reason is because if you're writing those classes by your perception, that code may not be hit. You may look like you've got 100% coverage, but what you've got is a maintenance burden of code that nobody ever uses. When you need to refactor some of that code, now all of a sudden you've got to do more work to support all these methods that nobody's ever going to use. Think about your requirements coverage. I don't want anybody to take away from this that, well, Martin said I shouldn't write any unit tests anymore. I will deny all of it. There is too much in our industry about cargo culting. I watched a conference talk, therefore I did the thing, therefore I cannot be wrong. You're all intelligent people. Use that intelligence. Think about what you're doing. Write the tests that matter. Think about the gears that you're in. And that's it. That's all I've got. So if you've got questions, scan the code. It'll come up on Slido. That's for the day, so feel free to come and talk to me. Do bear in mind that most of the speakers, if we're stood outside there, you are free to come and talk to us and ask us questions. We love it. These are what I get talking to you guys about what is happening. So do come and talk to us. I'm also on, I think, in room 3 after lunch, talking about open telemetry and observability in general, with an emphasis on .NET and how to use it in a practical way. But other than that, thank you very much for coming.